are having 0 in their sign bits. So if we perform an XOR operation, we know that if the levels are same, then the answer will be 0, and if the levels are different, then the answer will be 1. That is, if it is 0 0, it will result in a 0. If it is 1 1, it will again be 0. But if it is 1 0 or 0 1, then it will be 1. So if the answer is 0, then we'll subtract, that is a plus b complement plus 1. And if the answer is 1, then we'll go for addition. So similarly here, if the answer is 1, then we'll go for subtraction, and if the answer is 0, then we'll go for addition. Okay, so if an overflow occurs in addition part, then that bit is stored in E. And if the first bit in the result equals to 1, then a shift right operation is performed and the data contained in E is shifted into A1, and an increment of the exponents is performed, and then finally the operation is terminated. But if it is 0, we don't have to perform any of these operations, and directly it's a termination of the operation. So here, if the not sign bit, if the first bit of the result is 0, then you have to perform 2's complement and you have to change the sign as well. But if it is 1, then there will be two conditions. A will be equal to 0, then the entire floating point data that was stored in AC will be equal to 0, and termination will occur. But if it is not equal to 0, then again a different condition occurs. And see, when you apply 2's complement and change the sign, the data is stored in another variable, and that variable is A1. And when this A1 is equal to 1, termination occurs. But if it is equal to 0, again you have to shift left A, not A, you have to shift left A, okay, the previous A, okay, and decrement the exponent, and this process will continue until you get the value of A1 as 1. So this is all about the floating point arithmetic operation. Thank you.